recording. Yeah. Excellent. All right. Welcome back, everybody. This is part 2 of 4 of the Applied Clean Code series. Yesterday we took a look at simple design. Today it will be developer testing. And today we'll have a bit more code than yesterday. We will have a hands-on session on day 4, which is the day after, where you will get to try out everything that we discussed today. So the same rules hold. For please be engaged. For every right answer or approximately right answer, or even otherwise, you get a chocolate. Can anybody tell me what the picture on the top right is, or top left?
Is it Westminster Abbey?
Westminster Abbey, is it?
Okay, I don't know, but okay.
We all get one.
Where
We
else?
just say
Where, okay, hint is it is in one of the books, just like last presentation.
Oh, I see.
Okay, it's from the Test-Driven Development by Example by Kent Beck, the defining treatise on TDD. But yeah, so it is. It could be Westminster Abbey. So since I don't know the answer, you do qualify for the chocolate. Okay, so this is the same guy, same cat. No differences there. Agenda. So we look at types of tests. So what do we mean by unit tests? What do we mean by integration tests? And it helps to get the terminology right so that we know what we are referring to. Then in the extreme limit of developer testing, what happens? What really, how does the code behave? What happens to the tests? We'll take a look. We will go through systematic 7 levels of developer testing, starting with manual tests done by a different team all the way to hardcore TDD, right? And we'll see how things evolve. What are the stages? How does the progression look? We will look at a sample architecture that supports TDD. That supports developer testing, and we'll see what the benefits of that is. It's just to show that it is possible, for example, to write a fair bit of code with no mocks, for example. We will look at some high-level decoupling techniques, right? How do you decouple a piece of code from another piece of code so that you can get it under test? We'll do a demo of TDD. I'll be doing a demo of TDD, and you will get to repeat this on day 4. And then we'll take a look at a couple of sample True Blue TDD projects. And finally, we'll just review what in the extreme, how things look. So the types of tests, right? So it's important to get the terminology right so that we know what we're referring to when we say integration tests, unit tests, acceptance tests, right? This should not be anything new because we're already very diligent from what I've seen in EDMI about getting our tests right, doing them fairly rigorously, right? So this should be fairly well-known information, but I'll just run through it anyways. Now, unit test is something that tests exactly one aspect of a responsibility, and responsibility as defined by SRP, right? So single responsibility principle, it's the axis of change. One unit test will test exactly one aspect, no more, no less. Integration tests can be short range or long range, and integration test is the next level, which is essentially multiple responsibilities or multiple facets, right, of a single. So it's just a chain. It's just built up in the next.
Should or should they not hit the database?
Not yet.
Okay.
Platform tests are the tests that specifically targetedly test your assumptions in the platform. Like, for example, this is where probably you will get a DB. Like if you've built a database layer and you want the database layer, that data access layer to behave in a specific manner, you would write targeted tests that just tests your database interaction code, right? So it has nothing to do with the product; it's just that layer.
Right.
So that's hence the name platform. We will come to see some pretty funky usage of platform tests and how they help in decoupling the overall architecture. Like I said, an acceptance test, of course, we know is the end-to-end test. This is the proof that the sprint is done, and this is typically an end-to-end customer scenario.
So that's our system test.
System tests, correct. That's what we call system tests here. And of course, a very crucial part, a very critical part is the exploratory testing. And these are essentially business domain experts who manually test the overall product. They apply creative thinking around. Mainly, their purpose is to the job is to prove that the code or the feature that has been delivered measures up to what the customer will want. So they are not tied by what the product owner has defined. They're not tied by what the developer has written. Their job is to make sure that, hey, is the customer getting what he really needs, right? So this is a very critical part, and of course this has to be somebody with fairly good knowledge of the business. I believe we call this the solution testing here. Correct me if I'm wrong.
Yes. Okay. You're right.
And of course we have other hosts of type. We have pre-built tests, like something that tests your architecture rules, like you don't want dependencies going top down versus you want them to go bottom up. So those kind of tests you put it before the build itself. You have perf, scale, back compat, and any kind of automated thing. So any kind of thing that can be, the principle is anything that can be automated should be automated and checked into the source code, right? So that way, you have a clean. So this is a high level, summary, and so let's get on to the next section, right? Now, let's paint a picture, right? So what happens, and this is something just imagine for a moment, right? Just humor me and imagine, like, what happens in the limit, right? When you're extremely skilled, like you've reached, and there are people like some of my mentors are work at this level, right? So what do they look like? What are their code, right? What happens, right? So with extreme developers testing skills, and note that I haven't said unit testing here because developer skill is essentially the entire suite, right? So while unit testing should do a lot of your stuff, it should give feedback on the design. Exploratory tests are equally important, and so are the entire range that I mentioned earlier, right? So wherever there is some opportunity to automate, it should be automated. Now in the limit, what happens, right? In the limit, each unit test becomes 3 lines of code. Each unit is around 3-4 lines of code. These are just approximate numbers. They could be like sometimes 10, sometimes 1. At max, 1 test double, no mocks, no inversion of control or DI containers in the tests, right? It could be in the product, right? So nothing superfluous. It's just pure code testing code. One issue, 1 unit test fails, and 0 debugging required. Now, well, typically one issue, 1 or maybe a few max, right? You won't have about 5, 10, 15 failing, right? The critical thing here is that you won't require debugging, right? So your failing test will tell you exactly what the problem is. 2,500 tests running in 40 seconds, yielding around 90% code coverage. This happens. This is you don't have to be extremely skilled. I have run teams in the past that have done this, right? I wouldn't say we're extremely skilled. We're reasonably skilled, right? And this is real. There is the Roslyn team, which one of my mentors told. Roslyn is the compiler team, C# VB compiler team. At least when I was back in Microsoft in 2012, they had around 20,000 tests running in 5 minutes. And this is just code testing code.
That's just unit tests.
That's just unit tests, right? Of course, Roslyn is an extreme example because Roslyn is a class library. It doesn't have integration with other external things.
Yeah.
But nonetheless, it just shows you the power.
Yeah.
Right. The 2,500 tests in 40 seconds, that is like an entire product. I'll show you what the product looks like. And if you guys are interested, I can walk us through a sample project. I will give examples, but probably not walk through them. Now, what does TDD get you, right? So TDD, so while I'm saying TDD, again, TDD has various gradations, and I'm using the term TDD interchangeably with developer testing, but let's assume that TDD at its extreme, what does it get you? So first and foremost thing is it's not test driven development, it's test driven design. So it gives you design feedback. So anytime something is hard to test, anytime you require a mock, and again this is in the extreme, I'm not saying we need to get mock free day after tomorrow, but eventually when you start becoming more and more skills, the TDD pushes back on the mock. So you cannot do test driven design with mocks in your code, right? So design becomes very loosely coupled, like the example we saw yesterday, highly cohesive and fully dry. Right, this is the example that we got yesterday of the emergent design. If you guys can recall the picture from the last but few slides. So that's number one. Number two, a body of tests develops with your code, right? So you are no longer one corner case broken somewhere and your commit will not go through simply because it takes 2 minutes to run the test, right? So 20,000 tests running in 5 minutes is just spectacular, or 2,540 seconds is just spectacular, right? So and you're not spending additional, well, technically you are, but at the same time both are getting developed at the same time, right? So they come hand in hand. So test code is testing your developer code is in turn testing the test code, right? So it's like a two-way system going on. Your code becomes clearly documented, obviously, because tests serve as the specification for your code. And I'll show you examples for all of this, right? I have sample projects that I'll show you. Debugging and stabilization time is down to 0, right? So this is something spectacular, and this hits you once you start seeing things in action, right? So debugging time is pretty much 0, and stabilization time, I mean, once you have written a bunch of units and getting an end-to-end scenario by wiring up the units together, there is some magic that goes on that, integration becomes very easy once you have unit tested each of your thing, and I still can't explain why that is, but it's just remarkable. It happens every time, right? So that's what I mean by stabilization time is down to 0. Again, coding units can be divided into mutually independent tasks. So once you get your design right and once you're doing the testing, so while your developer testing in the extreme looks like you're doing double the work, you are actually getting back a lot. So eventually, over the course of a sprint, 2 sprints with a reasonable skill set, it turns out to be much cheaper, right? So that's my personal experience. So this is in the extreme what happens, right? This is just keep it in your mind and just humor me for a bit, right? I'll take you through this. I'll show you the examples. Now let's understand what the levels of, what the progressions of developer testing is, right? Through the entire, like how does one a new developer joining the team, a new developer, I mean a fresh graduate developer joining the team, how he can progress through, right? Or a team that is starting to do testing, right? Then the initial levels don't apply to us in EDMI because we already passed the initial levels, but it's sometimes good to go through, right? Just to be cognizant of these. So clearly level 0 is manual testing by testers. So I don't think we do this here at all, right? But we used to do this in Microsoft. So there used to be 2 separate teams, one writing code, throwing it over the fence, and there used to be another army of testers catching that code over the fence. And
do they still do that now?
Some teams do it.
Okay.
Actually, a lot of teams still do it. So,
Okay.
yeah. And this is actually it becomes very unhealthy pretty soon. Right. Here, what happens is that you have long cycle times. This is where you have a development milestone and a testing milestone. Right, so you write code, keep writing code in the development milestone, and you really have no idea where you're going, and then you throw it across. And then after a few days, the developer loses track of what he is really done, and you get into no repro fight. Say, I can't repro it. No, tester says no, there is a bug. Developer says no, there is no. And since the cycle time is very high, there is no feedback to see the mistakes and the patterns of mistakes and what kind of preventions the developer could have done, beforehand. So there's a lot of loss of context here. Again, so now you need a bug tracking system because there are too many things coming back, and this further increases. You get into things like triage of bugs and most important bugs, and guess who's the entity supports this entire thing most? It's the customer, right? So eventually, in level 0, there are a bunch of crazy things that are done. For example, in Microsoft, like way long back, one of the criteria for a successful testing was the number of bugs you could file in the development team. Right? So that just becomes a very adversarial setup, right? People stop talking to each other and blah 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 blah. But fortunately, I think most of the industry is out of this phase. Right. Level 1 is automated testing by testers, and the difference between this obviously is the automation, right? Now here, testers, which are a separate team, write automated tests. Pretty much everything is same. They get the code from the developers after a long time. They write automated tests after the fact, right? After the entire scenario is ready, after the sprint is over. But here, thankfully, they have a no repro. There are no repro fights because they can simply run the automated test and the developer can know, okay, this is what you meant. And of course, this becomes your spec. Excuse me. Communication is slightly better. Still, you have lots of in-flight bugs. And these are full-on integration tests. Like, they're what we call acceptance tests today. The entire product, the only set of tests that exist in this system are acceptance tests. And since there are so many of them and they take so long, right? So you have only things like weekly, nightly, monthly. And I've been through all of this in Microsoft. So there is to be a set of tests we call build verification tests. Then there'll be nightlies. Then there'll be sort of tests that are run weekly, and sorry, yeah. My apologies. Okay, so that's L1. So yeah, thankfully we don't have to worry about this. Now there is the shift from L1 to L2, which is development with automated tests. Right now, test code is required for checking. Tests written after the code, right? But here there's a merging of the thing. This is where Agile has disrupted the industry, right? So you're saying that the same guy writes both the tests, and you mandate that before committing the code, you must have corresponding tests. And they are long-range integration tests and acceptance tests, but they are not really unit tests as such. They don't test the units or even a collection of units. They test the entire thing, but at least it's the same team that is writing it, right? And they're mistakenly called unit tests as they're written using a unit test framework, right? But the interesting thing that happens here is the cycle time and the number of defects drop. Simple mistakes get caught early, and early as in even before commit to. Right? So that's a beautiful thing. And cycle time, I mean, like from the time you thought that you will write the code to the time that you actually get to the bug that you've written, that time drops. But again, not much design feedback because it's still high enough because to have fast learning you need to have fast feedback, and the fast feedback is still not there yet. Okay, but note that the learning speeds up here simply because the same guy who is doing both, right? So he knows exactly what he has done, and therefore next time he doesn't repeat it. Right? Now that's L2. Now we come to L3 is L3A and 3B, and teams, the same team does both in parallel, around 50-50 split. L3A is unit testing with mocks, right? Actually, this is actual start of writing unit tests, right? Before this, we did not have unit tests. Before we had long range, not even long range, we had acceptance tests and all other, like really long range tests and acceptance tests before level 3. Now level 3 is where we actually start writing unit tests. Now design starts changing simply because you can't write a unit test without having minimum level of minimum bar for coupling and minimum bar for cohesion, right? You just cannot write unit tests. So therefore, writing this test pushes, like there's a constant tug of war between you having to write unit tests versus your code not being cohesive and being highly coupled. But thankfully we use mocks here, so that way but mocks don't really they don't really help in true decoupling, right? So mocks are essentially just a temporary tool, right? So mocks are powerful. Mocks have their place. We will come to it in the third talk that we have tomorrow. But mocks really have their limitations. So mocks decouple the code, but they give the impression that you're decoupling the code, but they're not really decoupling the code. Right? But you do start getting design feedback, and this is where the design feedback, this is where test-driven development starts changing into test-driven design, right? This is the first time we start seeing design feedback. Again, tests run fast. Refactoring is inhibited since mocks retain coupling, right? So one of my teammates...
When you say mocks, do you mean if a class takes a dependency on an interface and you mock that interface?
Yes, right? So that's exactly what I mean. Right, one of my teammates in the libraries team was, I think he made a comment the other day saying, if we change the implementation, it requires us to change the entire test, right? So this is exactly what is meant by refactoring is inhibited. So simply because you cannot change the code, simply because the unit test that uses the mocks is essentially looking into the production code and doing as per what the production. So therefore, the production code changes. You have to pretty much more often than not rewrite the unit test. So this is essentially where. So you get, so with every level you start seeing some positives, but at every level there are some blockers as well. Blockers to further refactoring and further design. Right. So this is the blocker for this. Level 3B is test first development, right? So you can complete, right? So here unit tests are written before the code, so it's really minor tweak to the level 3B, but essentially it's the same. It's the only difference is the unit tests are written before the code. Again, so now not just design feedback, you also start getting mini specs and documentation. So this is where the beauty of test-driven development is starting to appear, right? So every unit of code, if you're giving your library to a sister team, you can actually give them your body of tests as well, and the tests serve as your documentation or sample code, right? And mini specs. Coding becomes tight simply because if you're doing test first development, and I'll show you through a demo, you will simply not write any superfluous code at all, right? You will write this leanest, meanest, and the most elegant looking code that passes the test. That's the goal of, that's the mantra here. And obviously development accelerates simply because of various things coming into play here, right? So this is 3A and 3B. Okay, so here is where the magic starts. Okay, so this what I like to affectionately call as the black belt, martial arts black belt. This is the real. This is where we can start in test-driven development, right? This is just red, green, and refactoring. So all code is written by refactoring. So first you write the test, it fails. You write sufficient code to pass the test, and then you do a few tests like this, and then you remove design smells. And pretty much the only design smell you remove is making it dry. That's pretty much it, right? As we've seen yesterday, right? So dry violation is essentially the mother of all design principles. So every design principle is attempting to solve dry violation in some form or the other. Right here, important thing is all code is written by refactoring, right? So you don't write code first. You write code as a means to pass the test and as a means to make it look elegant, right? Every code change is also done through a red-green refactor cycle, so which means if you have a bug, if somebody has reported a bug to you, your instinct is to first do a simple test that reproduces the bug, and then you do a test-driven bug fixing. Cycle time really drops now, right? So now you have essentially a very clean picture of what because your specification is there, your design is less coupled, highly cohesive. So therefore, like your code is very readable, code is highly encapsulated, code is highly, you can pick your code and run it independently. So all these things make the cycle time. And when I mean cycle time, I mean from the time that you've had a thought about a particular code and you translate that thought into your code to the time you figure out issues in the translation, that loop becomes very fast. And if people are pairing, they can essentially push in code every 15 minutes, right? Just push through code and every 90 seconds or so. These are some just random numbers. Well, not really random, but they're just indicative numbers, like how fast things become, right? And then now, of course, we have design start point. This is what the emergent design we were referring to yesterday. So you don't design upfront. You are very clear about the specification. You are very clear about what the code does. You are very clear that you do not want dry in your. You want to be dry in your code base, and those two conditions essentially lead the emergence of whatever design. Right? There's a saying, right? You design for today and code for tomorrow. So this is where you start seeing that. Again, so no upfront clean code design is required anymore, so you don't need to design at all. So, but when I say don't need to design, it means it's not like we're going to be cowboys and start banging the keyboard. It means that we are very clear about what unit we're writing. We're very clear about what the unit is going to do. So the specification we know very clearly, and we're very diligent that we will stick to solid and dry. Right?
So what happens if you don't know what you're preparing? Do you do sort of like a mock-up first without any tests and go, okay, that's a good picture of what I want to do. Now I'm going to go through do it in the TDD way?
You could do that. You could do that, but once you've been operating at this level, right? you will rarely need to do that. So
I just find a lot of the times when you have sort of a problem that you're trying to solve, you don't really know how you're going to solve it. And I guess in my mind, I like to play around with a bit of code first, and then sort of, which kind of kills the TDD a little bit in the sense that if you're doing it that way, you're writing the code, playing around with it, but it seems like you kind of want to do that first, get an idea, and then maybe go back to TDD.
So there's no absolute answer, right? So one of the things that I have done in the past is essentially paired up with a buddy. Like we have both of us put our brains together and we have drawn on the diagram, right? Saying that, hey, here's this box diagram. This is what the sequence is going to be. This is what the data flow is going to be. This is what the control flow is going to be.
Yeah.
Right. So that sort of clarifies a lot of the stuff, a lot of confusion. That's number one.
Yeah.
So if you have like a block diagram of 3 blocks and you try to figure out the interaction between two, you will pretty soon know what you're expecting of each unit there.
Yeah. Yeah.
So that's number one. Number two is there are cases where, say there are external libraries or external frameworks or external platforms that you want to get hang on. So that you have to play with the code. So you're right about that.
Yeah, yeah. Okay.
Right.
Yeah.
So, and again, there are a bunch of techniques. There's no one right answer. So
Yeah, yeah, yeah.
so you get the idea. So, okay. So now, this is actually pretty cool. I'll give us examples. Again, so we just refactor, and design emerges, right? So I'll give us examples for this. Just go on to the next one. This is the ultimate. This is the red build, and this is not everyone operates at this level all the time, right? I have about a couple of mentors that do this whenever they get in, but it requires some real skill. It requires real skill. Right, but it doesn't mean that you can't do it. You can do it. It's possible, but you have to have really good skills. Now this becomes test-driven design, so it's not about development anymore, right? Here, your sole focus of writing any code is testability, right? So that's the primary design pivot. Your design pivot is not making it performant. Your first design pivot is not to make it performant, not to make it secure. Those come along the way. Right, but your first design pivot, your first design principle that you're trying to follow is, can I make this piece of code that I'm writing testable, right? So, and testable implies decoupling. And now, more testable implies more refactorable, which is high cohesion, low coupling, and good encapsulation. And you're really writing code, and you're writing code. You're writing code for the long haul. Let's put it this way, right? Your code might be serving a specific purpose, but as we've seen yesterday, right, we can just take that code and if you move to a new team, and all of a sudden figure out that, hey, yeah, I wrote something like that approximately in the previous team. More often than not, you can just take that code and its tests and drop it in the new team, and it should work with tweaks. Right. So this is where you're designing, you're coding for tomorrow and designing for today. There are no mocks anymore at this level. So this is that's why this is really hard. But it's possible to operate in this level. Now, only highly testable code can be really tested without mocks, obviously, and which means you get real-time feedback on design. So, moment you place the constraint that you can't use any mocks, it really forces you to think, like how can you make your design better?
I'd be interested to see that because I don't know how you do that.
Yeah. We'll go through some examples. Anyway, so these were again, so there's no one design. This is like you have to make mistakes, and you have to build it's like learning a language, right?
If you're removing mocks, what are you testing? The domain model,
the
model, and but you're not, obviously you cannot talk to the database.
I'll take us through example of exactly that. Yeah. Right, short answer is think EF core in memory.
Yeah. Okay.
Can I just chase that question with another one?
Hang on.
Are you using mocks? What are you actually testing?
Good question. Please hold on to that. I will show us an example of. I think it's probably in the next slide or the next to next slide. I'll show us how that's possible. Okay, but again, so don't let the phrase without mocks throw you off. So it's okay to use mocks, right? But again, using mocks everywhere is a problem because mocks give you a false impression that your design is decoupled. Mocks really don't decouple your design. Mocks just create an illusion that your design is decoupled. right? But I'll come to it shortly, right? It's good. I think I have touched a few nerves, so that's nice. I think people suddenly woke up. Okay, fair enough.
I was listening.
No, I meant the mocks thing.
Okay.
Yeah. Now again, so you have to build hundreds of. So it's like learning a language, right? So nobody knows English fully. Like, there's no such thing as perfect knowledge of English, and English is phrase, and the bunch of us in development speak different English from the bunch of them doing research in neuroscience, right? Even though most of it is common, but there's a lot of phrases that we'll probably not even understand. So it's very contextual, but again, you have to build. This is something this is where the practice is. This is lifelong. And remember, it's red belt, right? So red belt, I think, in one of the martial arts, red belt is essentially a lifetime achievement. It's not some level that you get to day after tomorrow or with practice, right? So this is like this goes all the way. This is like yeah. Okay, now this should, I'll just ask the same question periodically. Now this should give an idea how the picture I painted is possible. People still have questions, just hang on. It's fine, the doubt is fine, disbelief is fine, yes, that's what. Okay, now here we come to an example of how we can get rid of mocks, right? Again, so it's not a religious battle. We are not fighting a religious battle to, it's not some, wipe out all mocks philosophy or wipe out all mocks movement I'm starting here, or I'm asking us to start. The only point here is that one mock is fine, maybe two mocks are fine, but three mocks should raise a flag. Four mocks, something is really out of whack, right? And from then on, like, so every time you use one mock, it should really there should be something bothering you. Right, but hey, it's not a religious battle, right? At the end of the day, we don't want perfect code. And remember, the red belt level is something that you can do like after maybe 30, 40, 50 years of coding, right? And somebody like Dave Cutler or somebody like Ardo Belchi, these guys can do it, right? Okay, so let's get on to it. Right? Now, here is an example architecture that enables mocks without mocks, right? Now, this is hexagonal architecture. How many people have heard of hexagonal or clean architecture? Okay, somebody in Brisbane?
Can I say I have just like no,
Yeah. You heard it, right? Haven't you heard
I
it?
haven't actually
Okay.
heard of hexagonal architecture, so
Okay, you can hear it here. Okay, so again, it's more of a template. It's not something that you start out with. You let it emerge, right? But sometimes it's okay to follow take it as a starter kit kind of thing, right? At a high level, it's really dependency inversion principle at a product, at a product architecture level. Right? So how does it look? Now, RM happens to be one of my old, the last team I was working in Microsoft. Right, this is a team that I ran, and it's the Visual Studio Release Management, DevOps, Azure DevOps Release Management. Right. So RM had obviously a bunch of dependencies. We have Source Control Manager, BSSF. We have test tools, worker integration, and of course Azure. Right. So RM is an Azure service, right? So release management is an Azure service. Now each of these are essentially external systems, right? And an environment is essentially the Azure environment, or it could be like configs and properties and things like that, right? Now check out the design, right? Okay, and why hexagonal? Why not heptagonal, or why not octagonal? Yeah, sure, you can put it like it just means that there is a core and there are boundaries, right? Now these are ports. Okay, these are ports, okay. As in your USB port. Right. So this is a place where you can jack in some stuff, right? So Azure is a port, and simulator is an adapter. The platform, Azure platform, is an adapter, right? So you just jack in an adapter to a port, and you can put in as many things as you want. Right? So this is why it's called ports and adapters hexagonal, right? Hexagonal is misleading, but you get the idea. Now, what does it really mean, right? So we have release management. Forget all the fluff. So it basically means we have an Azure abstraction interface, and I'll show you what that looks like. Right? And we have two implementations of that. So when I say Azure, it's really Azure storage, right? Let's just limit to that. There is an in-memory simulator. Just hold on to your disbelief for a bit more. Right. So there's an in-memory simulator, and there's an actual platform implementation of that abstraction interface. Now the key thing is the code inside RM really doesn't care. If it is talking to only the interface, if it is dealing only with the interface, it really shouldn't matter to it. whether you're giving it a simulator or whether you're giving it an actual platform. Is that statement correct?
Should it know there's a difference? No.
Shouldn't know.
It shouldn't know there's a difference, I would say.
Is that always the case?
I would have thought so.
If you've done it right.
Okay. What does if you do it right mean?
Means if it knows the difference, then you probably did something wrong. Potentially.
If you're doing code to say, yeah, if the
You've
interface
created
does
a
something,
dependency
yeah.
on something that shouldn't be dependent.
Yes. Anybody else on the call? The question is does this architecture look like, can the RM hexagon really be unaware of which implementation it's being supplied?
Isn't that one of the solid principles? I forget the name of it.
It is DIP. It is, yes, it is. It's not just DIP. It is OCP, open closed principle. It's LSP as well. You're right, but can I just simply jack in things like this without things breaking? What's the guarantee that RM will work in a certain way with in-memory simulator and RM will work in a different way with the actual platform? I mean, there's no guarantee. Just because you've done an interface doesn't guarantee anything. Okay.
Depends how good the simulator is, doesn't it?
Sorry?
Depends on how good the simulator is.
Yes. So we'll define that more concretely. We'll prove that they're both equivalent.
Well, both implementations would have to basically adhere to what the specification of the interface is.
Yes.
And if they do that differently,
Yes.
then
Yes.
woohoo, yes.
Okay, we'll show how. Okay, so hold. Okay, now what is the configuration for unit test? But I'm still waiting the core question saying how can we assure that both are same, right? So this is the configuration for unit tests. So you have an interface and dependency injection and everything is fine, but in your unit test what you give it is in-memory simulator. So I'll show us an example. So when you say blob, it is an I blob, but the implementation of that I blob is really a blob, in-memory blob, right? And it does exactly the same set of things. The key is how does it know it's exactly the same set of things? Hold on. Now, when you're actually running unit tests here, now the unit tests are not going to use any mocks at all, right? So even though there is an interface, there is an actually real implementation behind it, right? So in the unit test, what you do is new in-memory blob and pass it on to some code in RM that does whatever.
So you would do this for unit tests as opposed to integration tests. You do it at the unit test level.
Yes, this is the unit test, right? There's a subsequent, right? So this is the unit test configuration, right? This is very subtle. Just it's a lot of fun as well. And I'll show you code examples of the very same scenario. Now think blazing fast, right? So this again, one of my mentors, he was saying that there was a team in Microsoft that was doing 76,000 Python tests and in 5 minutes, and that Python test, while people are waiting, it would draw some fractals on the screen and make it all very. But the point is, it's just blazing fast. Now you don't have dependency on Azure anymore. You're doing unit tests. You're doing in memory. Everything is in memory, and you can blaze. So with this design, right, my team had done 2,800 or 500 unit tests in 40 seconds flat, boom, right? 85%, these are some approximate number, but here is the significant majority of your coding and design happens with this configuration. So really you don't care about in-memory simulator for most of the times. There are cases, I'll come to that, and that's why it's the 85% or more, right? Now, majority of the team is shielded from even talking to Azure, right? Majority of the team, most of the time, let's put it this way. Here, in-memory simulator is not the Azure emulator. It's just a point to be noted. It is real, like in-memory storage simulator, right? Now, what is the configuration for platform tests, right? So the configuration for platform tests is you're just testing the interface here, right? And you're giving it the actual platform implementation. So if you say a blob, and if you say I want to upload a text file to the blob, what you do is in your unit test, you'll create a new Azure blob.upload some data, and then in the next line, you will download the same data and ensure both are same, right? Assert both are the same. So this is a platform test. So these are checking your abstractions, the interface that you have exposed of your Azure platform. And again, this Azure abstraction interface is not some generic, it can't be used by any product. It is very specific to your product needs, right? So it will bypass a bunch of, it will not expose things like, secured access token, for example, or it will not expose anything that your product doesn't need. So anything that RM needs, only then, right? It's just in time stuff. So therefore it evolves. It's not something you design upfront. Now platform definition, right? So it's something that we don't own. clearly Azure is not something you own. Our knowledge is partial. Capabilities and nuances are evolving. Azure continues to have version changes. APIs continue to have version changes, and we expect the underlying platform to evolve and change unpredictably. Right. So this is a classic platform. This is a classic scenario where this is where we get hit by a lot of issues when we're actually doing full solution development, solution architecture. Now, what happens is this is obviously this can't be run in every commit because this is going to really go to Azure. So what you do is you have a rolling build, and then maybe 100 of these will take say about 15 minutes, 20 minutes. So then you keep a rolling build, and it clubs every few check-ins, and keeps running them. So anytime there's a failure,
is it worth running these tests on the in-memory class to verify that both the actual platform
okay. Yeah.
Okay.
Figured it out. Okay. You figured out. Okay. You figured out. Okay. Now these validate the assumptions on the platform. So if the assumption on the platform, remember these assumptions are the assumptions that you're going to be making in your real code base, right? Your actual code base. If these assumptions are falsified anytime, then you would want to come to know of it immediately. So if your platform has broken, say, a contract with you, this rolling build is going to go catch it, right? And then if the rolling build fails, and you haven't made any code changes, you know exactly what the problem is. Problem is on the other side of the fence, right? So now you can give your platform guys an example of something saying that, hey, you guys told us this is going to work this way, but guess what? You guys broke us, right? So now it becomes communication. It's not a blame game, but communication becomes very very crisp and clear. Again, this requires deep understanding of the domain, right, and understanding your needs as well. So it's not like about 10% of the coding, because this requires understanding of security layer, understanding of various nuances, understanding of what is a partition key, what is those kind of very nuanced. Okay, what is the configuration for acceptance test? The acceptance test is essentially a customer scenario. So in the acceptance test, which is essentially the product running, you supply the actual implementation of the platform, right? So this is where the real product is running. Now this may not, given acceptance test might just test, say, RM launching and fetching the user's release management definitions from some repository somewhere.
And it's more just a happy path, would you say?
It
As
could be
opposed to testing?
Yeah. It is the customer scenario that is
Yeah.
more or less a happy path. Maybe one or two tweaks will be there, but more or less happy path. Yeah. Right. It is the singular proof. It is the only proof that the sprint is complete. Right. So all your unit tests, all the platform tests, none of them imply your sprint is complete. Sprint is essentially product owner will be happy only with this. Product owner doesn't care about. Thankfully, they don't care about the other. So here is the example that I was referring to, right?
Can I just ask one question?
Sure.
With the in-memory thing and the actual implementation, how do you handle exceptions? Should you be handling platform? So you shouldn't be handling platform-specific exceptions within your whatever using the interface?
No.
So you'd want to translate those.
Translate that into exactly what you need. Right. Sometimes you might want to eat it away simply because your platform doesn't care, or your core product doesn't care.
Yeah.
So let's just go over this, right? So this is the very thing that I was referring to. Only if my thing launches. Let's go to the blob thing I was referring to. So definitions, blobs. So this is what a blob looks like. Boom, boom, boom. And obviously Azure blobs are much more powerful than this, but this is essentially what the typical product at that point of time needed, right? Right. Now the question was, how do we know that the two implementations are the same? Right. So that was the question we had asked, because if you're unit testing with a particular implementation and the actual implementation differs in behavior, then your unit tests are useless. Right. Really, they don't mean anything. Okay. So this is how we prove it. So the definitions have something called definition tests. Check this out. Blob tests is an abstract class. Okay, and it has some facts here, which are tests. And what do we have here? We have something called a blob client, but even this test doesn't know which blob client it is. But it is testing it. Right? So whatever blob client is given to it, it is going to run this line of code, or this line of code, or this line of code. Everyone clear so far? So This is an abstract class. This has a blob client, iBlob client. This is an interface. This test does not know what that actual implementation, underlying implementation is. It doesn't. It doesn't. Which means whatever test is running here, if they are passing
So is
for
this the unit test or the platform test?
this is the platform test,
Okay.
right? So whatever implementation you give it, if it passes this, then by definition both are identical. Both are isomorphic, right?
Sure.
So they are mapped. They have the same behavior.
Yeah.
Now it could be that for some other behavior in-memory simulator might crash and your Azure platform might work, but you don't care simply because that behavior is not interesting to you.
Yeah.
Right. So you essentially have the same test code, and check this out. So let's go to Azure, blobs, blob. So this one, I'm sorry, my bad. So Azure platform tests, blobs, blob tests. So here we are deriving from the abstract blob test and we're simply giving it a blob client that is the actual blob client. Similarly for the in-memory corresponding in-memory test, there is a corresponding in-memory test for everything. Right? We'll give it the in-memory platform. So therefore, we have the same piece of code running on both in-memory as well as Azure platform. Mm-hmm. So they are guaranteed to be compatible, right? So this is the proof.
Yeah, I think what we've done it in Storm where we've mocked out things like Mongo and stuff like that. But I think having these adaptive tests, platform tests would be really good because, yeah, there are some discrepancies between.
There are some discrepancies, and the key thing here is you have no longer used mocks here anymore, right? You haven't used mocks at all.
Yeah.
So you haven't done mock iBlob at all. So you're actually running the real code here.
Yeah.
Right.
Yeah.
So this is essentially where your design starts. You have similar ones for file systems adapters. So essentially, I mean, pretty much every product I go, I know whatever I needed, I just write it at that point of time. And since it's very contextual, right, you cannot reuse across. Well, for the most part, you cannot just translate. Azure happens to be one of the common platforms everywhere, so it lends itself to usability. But here's an example of a file system. What's the example of a SQL port and adapter? Guys on the call, looking at you. Okay, hint A, B, C, D, E, F. Entity framework?
Yeah.
In-memory they have an in-memory. Although I don't know if they have done a similar guarantee for in-memory, but it goes along that line, right?
Did you use that?
Yes. Well, yeah.
It's not very well designed.
It's not very good.
Yeah.
Right.
They don't have this guarantee there, right? I think it's hard.
And we used what's the other one? The mini SQL server thing. What's it called?
The CE.
SQL.
Yes.
Oh, is it called like now? Is it?
Yeah, that was better.
That's a bit more compatible with SQL. Anyway,
But that's actually hitting a file, isn't it?
You can do it in memory with it.
Oh, okay. Cool.
That's what we ended up doing. It's okay.
Yeah. So and you can write your own, right? Whatever suits you, go for it. Now we'll
I guess it with the adapter, if it's just something like insert customer, then that's quite easy to do an in-memory version of that adapter, right? Is that what level you would be doing at?
Yes.
Or are you looking more at, well, I suppose you'd have to do it at that level, wouldn't you? You couldn't go
Yes.
down another level. So
if necessary, you would go down. But if insert customer is the only thing that you're doing across the product you care about, then you just
yeah.
You're assuming that you're not going to then try and query that. Yes.
Well, your in-memory is going to have to be able to handle that.
yeah. Okay, a time check. So I think we started 5 minutes, 7 minutes. No. You can continue this discussion. So we started, I think, let's say 10 minutes late. So we are essentially 15 minutes behind, 14, 13 minutes behind, 30 minutes away from this thing. So I think we're running late. So here are some high-level decoupling techniques. Right? These are at a very high level, but again, you have to evolve your own, right? So for example, a couple of examples, right? So the most common thing that a person with minimal coding experience will do is direct member call, right? So this, you can read it, but you can't test it, right? So to test it, you have to test everything that has been called along the way. Lesser coupling is coupling through interfaces, and again, this requires mocks, right? But you would now need an interface for every class, and this is just one of the ways to do it, right? So even though this is less coupling, this is not the only way. Even lesser coupling is through interfaces with a single method, also known as functions, right? So this is where knowledge of functional programming will really enrich your, and I'm very interested to do a functional programming session if you guys are interested. But this is where functional programming essentially starts showing its metal, right? So this is where you start building a repository with FP principles. It's a bit less readable, but it's easy to set up, easy to test. It's a function after all, right? And then finally, 0% coupling is through events, right? So all you do is expose events and edit. So you just test that, hey, this event has been fired, and the subscriber to an event is just nothing but a method. So you just call that method. So they're completely fully decoupled. Now these
Started doing that now with a mediator.
mediator. Mediator is an example. That's true. Right. So the idea is that overdoing any one of these is a bad thing, right? So it's essentially you are cooking something. You are in the process of cooking, right? It's a nice mixture of all kinds of ingredients. That's what is going to get you the best recipe. Right. So eventually you need to build your own mental repository of decoupling techniques, and how you build it is essentially you play with it, you speak to people, you pair up with people who have done this before, and you read up, you look at sample code in various ways. You have to be immersed in it, and you start getting ideas. You have to also be familiar with the functional programming principles, the logic-oriented programming principles. There are various paradigms, right? So more of this, the more decoupling techniques you'll know. Now, check out some very creative decoupling techniques in this video. This guy is really good, right? He's one of my mentors. He's one of the guys who I went and learned stuff from. And his blog is here, so you guys can go have some fun here.
Are you sending out these slides?
I'll send out the slides. I will. Right now, I would like to do a demo of TDD. What I'm going to do is the demo of TDD I'm going to put towards the end, so that if people are interested, they can stay back, so that at least we cover the content. Right now, so the TDD is really red, green, apply, dry, right? Become dry. Rules of engagement are: there is a red phase where you write only the minutest possible failing test. Right? It's as simple as that. Right? Then there's a green phase. You commit all sorts of atrocities and sins to get the test to pass. Your only goal is to get the test to pass and to get to green as soon as possible. Right? Really as soon as possible. Then there is a refactor phase to become dry. Right? Undo your sins. This is where you get chance to redeem yourself.
That's your sins.
Redeem yourself of your sins. Right? Now TDD is what I'll be demonstrating towards the end of the thing is essentially a kata. Kata. How many people have done katas or heard of katas or know katas? Okay, not many. Okay, fair enough. Now this is a martial arts term. Remember this, the Karate Kid movie? So where this little boy is going to go to Jackie Chan, and Jackie Chan is going to be a recluse, and the boy is going to tell Jackie Chan, hey, teach me karate. So Jackie Chan will basically give him a
remake.
That's
That's the remake.
That's the remake.
That's the remake? Okay. No, this is a movie. This is a Karate Kid.
not the original.
Yeah, but it's not the
Oh, may
original.
not be the original one. Yeah, this is the one I saw. But the point is,
You can tell who the old people in the room are.
the whole thing. Okay, the point is Jackie Chan is going to give him a piece of, I think he's going to give him a shirt, and he's going to give him a clothes line, and he's going to say, hey, with this exact movement, put up your clothes, right? And do it, he'll say, do it 500 times a day, or how many ever, like 100 times a day. So the boy is going to continue doing that, and I think after the month or after 2 months, the boy is going to get really bored, and he's going to say that, hey, I came to learn karate from you, but what is the shit you're asking me to do every day? I'm done with you. So at that point
In the original one, just so you know, it was painting up and down like this, and wax on, wax
You got
off.
You got it. So as soon as the boy says that, Jackie Chan goes and attacks the boy, and guess what? The boy's autopilot takes over, and he does the clothes movement thing. So that's his defense. So then the boy understands that, okay, you know what? This is what he was trying to teach me all along. So I do know karate, right? So the whole idea is that some of these skills, right? Some of these new skills like functional programming or test-driven development or legacy code refactoring, there are specific katas for this. The katas look very trivial, but they essentially achieve the same purpose. They get you on an autopilot. I can tell stories and I'll show you an example, but we'll leave it to the end so that people who want to can leave, but rest of the guys can stay back and we can have some fun. Right. So this is going to be a bowling game kata. Right, I'm going to come to that towards the end of the slide section. Right. Here are some sample L5 to L6 TDD projects. Again, like simple design, developer testing principles are language agnostic. These techniques have been around since 1970s. Right, and they haven't really changed, right? Irrespective of all the frameworks and languages we have today, F#, Scala, Haskell, Angular, React, blah blah blah, name your thing. These principles are essentially timeless, right? They are the real software principles, right? So what I usually tell people is that, hey, focus on getting these right, and not necessarily your knowledge of. Of course, knowledge of frameworks is required, but knowledge of frameworks is not primary, simply because they're going to get outdated pretty soon. So an example is, you guys can go to this GitHub page. So this is a 1 year effort, part-time, while on sabbatical, and the purpose was just to learn F#. Right, it's a Visual Studio plugin that essentially does live unit testing. Right, it's a cheap knockoff of live unit testing, and this is before live unit testing. So and it is at the stage where it can dog food itself. Like, you can do TDD on TDD Studio using TDD Studio. So hopefully your partial didn't crash on that. So this is an example. Another example is FS5150. So this is an emulator for, I don't know how many people remember this. These machines, right? It emulates the CPU, it emulates the peripheral. Well, supposed to emulate the peripherals, but right now all it does is emulates the CPU and emulates the function set, the instruction set. And this was a test to see how far FP can go, right? Now it currently has a hardware debugger. It boots up from the BIOS, completes the CPU self-test, and the next step is to emulate the PIC and the timer, programmable controller, as well as the timer. Right? Both of these are done in L5 to L6. They don't, none of these have any mocks, so you can go check them out, and you can essentially start seeing sort of what it looks like eventually, the picture that I painted. Maybe I'll send across the slides, but these are the good things to explore, saying that, hey, you know what, it's possible. Right, both of them have been written by yours truly, and the example, the ability to write code without mocks, the ability to write unit tests at that minutiae, ability to follow refactoring techniques, these are all live demonstrations that these are possible, right? And these are non-trivial code bases. At least the first one is non-trivial. Again, this is the thing that I had earlier. Right. The key thing to note here is that exceptional code metrics, like hotspots, code coverage, they are unit test coverage. They are just a number of unit tests, the size of unit tests, the duration of unit tests. Those code metrics are just side effects. You're actually focusing on the skill. Your code is emerging, right? Good design, encapsulation, coupling, cohesiveness. These are just side effects of what you're doing, right? You focus on the skill. The rest just emerges. Right?
So how far do you go with the zero mocks? Like, if you had service A that relies on service B, when unit testing service A, would you create an in-memory version or some version of service B just so that you don't have to mock service B?
Personally, when I would do coding, it depends on the interactions between service and supposing it's a one-time service and it's a one method call, I'll probably just mock it.
Right. Okay.
But if it's a very coupled dependency,
yeah,
then mocks is not going to solve. Mocks is only going to make things worse.
Right.
So then I would go about doing a bit more of a long-term investment.
Okay. Yeah.
And also the fact that they're coupled so tightly means there's a good dependency. That
yeah.
means there are a lot of places they'll be touched. So it's eventually worth the investment to do a simulator.
Yeah. Okay.
Right. So it's like a
simulator. That's the word I need to use. Yeah.
Right. Anyway, so the key takeaways. I'll come to the demo of the kata. That's something that's really beautiful to watch if you guys can stick around. But this can be the last slide if you guys choose. Right. The key takeaways are essentially keeping track of the class of tests you're writing. Right. So this is essentially the awareness of what you're doing. Essentially forces you to learn. Right. This is something happens in the mind. It's a property of the mind. Right. As soon as you know what you're doing, you want to do it better. And this happens to everybody. Right. It's something in the human mind. Build a mental repository of decoupling techniques. Don't overdo either eventing, don't overdo mocks, or don't overdo direct method calls. And again, don't go out on a religious battle and try and remove all mocks either. So either way, it's Yagni versus Dry, right? So yeah. You have to call Yagni at some point. You can start with the top 4 in this slide, and you can go to Arlo's talk and see more. And and eventually you have to learn. You have to pair, and you have to kind of make mistakes, and you have to deploy bugs in production. You got to get kind of go to the really bad production bugs, and eventually it's a lot of mental scars, and eventually you will build some repository, right? Keep track of where in the 7 levels you are, right? So again, like I said, right, so there's something about the human mind where if you are aware of what you're doing at this moment, you want to do it better, right? And eventually you figure out ways to do it better. So keep track of where in the 7 levels you are. Developer testing principle is language, framework, tool agnostic. It's a thinking process, right? So it's the example I give is when you have an idea, the language you use, it could be French, English, or German. It could be your skill in using the language. Is essentially the idea that you're writing down. So if you have not a very good idea, then no matter how skilled you are in using the language, you're still going to have a poor idea. But if your idea is like really good and it's well formed and well structured, mediocre or medium or a reasonable understanding of the language will show that idea, right? It's similar. So code is nothing but our thoughts. We're expressing them as either C# or F# or whatever you call it. Right, so it's the thinking process. These things mold the thinking process. Developer testing, simple design is about the thinking here. It's no longer about code anymore, right? So that's what it irks me very much when people say solid is oh, solid is not oh, take it easy. Right, recommended books. Obviously, these are the wisdom of our forefathers. These guys are really good, like yesterday I said. But this is essentially are the 4 things that you probably most of the time there are more, but. Right, so I am done with the chat. I personally would like to stick around and see a demo of TDD, which I will be doing. But if people want, they can drop off. I will record this anyway, so people can go and see it at that time. Right, so let's go back to the bowling game. This should take about 20 minutes. Right, so feel free to stick around or feel free to drop off. Okay, so bowling game is simple, right? We've all played the bowling game. There are 10 frames, 2 rolls in each frame, and the score is combination, right? The score of each frame is number of pins plus the bonuses. There is a spare, there's a strike, and it's all standard stuff. Anybody doesn't know the bowling game or haven't heard of bowling game?
Yeah, I haven't heard of it.
Haven't heard of it? Okay.
What do you mean you haven't heard of it?
I mean, he agrees with me.
Oh, right.
All right, so let's build a library to calculate the bowling game. Right, so I'm going to open. This is the. I'm going to just increase the size maybe of this. I don't think it's very clear. It's fine. Okay, so bowling game. Let's do rebuild. We'll fetch all NuGet packages, and I'm going to increase the size. Fear not. I think 140 is the canonical. Yeah, I think that's okay. Okay, so the bowling game is very simple, right? So we don't have the code yet. We're doing test-driven development, so we don't have code yet. We have the test. All right, so that's the whole idea. Now let's think through, right? Again, so when we're doing test-driven development, we don't care about the code anymore, at least to start off with. Actually, we never care about the code, we care about the test code. So what are the tests we're going to write? So the first test I can think of is test gutter game. Like all the balls we have sent to gutter, right? So purposely or due to lack of skill, either ways. What is another test?
Test all strikes.
Okay, fair enough. Test, okay, test perfect game is one. Test all ones, just something different from gutter. I would like to test a spare. I would like to test strike. And I think, at least as far as the spec is concerned, if we can get this done, I think we'll see if we need to get more done, right? So okay, so typically this is what you're doing, right? So typically in when you're doing TDD, you're thinking of the unit and you're thinking of what the unit should do and not how it should do it, right? So that's the important thing here. Okay, so let's move on and write the test. Public void. Hey guys, to repeat, this is going to take 20 minutes, so people that want to drop off, please feel free to drop off. I will be recording this anyway, but if you want to hang around and take part, by all means, that will make it more fun. Right. So now test gutter game. So we're gonna obviously put this as a fact. Right. And how do you test a gutter game? So obviously we need something called a game. So var g equal to new game. The code doesn't exist. If that doesn't bother us, we're doing TDD. Okay. Now the problem is this is failing already. So what I'm going to do is I'm going to do something called a live unit testing so that it saves me the trouble of running unit tests explicitly. Right. So it's running in the background if you see, right? Now the thing is, I have written a test, but the test is not compiling. So my first order of business is to make the test compile. How do I make the test compile? Use the refactoring. So generate class game in the same file, right? Excellent. The test compiles.
Well, we lost you, I think.
We lost this room.
The meeting will have finished in the room, so you need to click check in or, book the room again on the tablet out the front.
This is Turing, isn't it?
Yeah.
And then you need to re-invite the room to the call.
Gotcha. Thank you.
So you can do it you can just make sure you do it on the screen at the front door. You don't need to invite it to the meeting or anything. You do have to redial it in the call. Actually, I can do it now. Are you inviting it? I can do it.
I invited in the call.
Just sending it for you.
Oh, there you go.
There you go.
Thanks, Adrian.
Cool.
Okay, we're back online. Okay, so we wrote the game. We have a good game class. We won't care about the internal organization. Let it be in the same file. None of that we care, right? We want to get our first test up and running. That's the purpose. We are on a mission to get the first test up and running. Okay, so great. We've created a game, but that's not the complete test. And we're letting the IDE generate all the code. We haven't written a single line of production code yet, and we'll try to keep it that way as far as possible. Right? We want the code to emerge. Okay, so what's the next thing, right? So we want to send everything to the gutter. So that shouldn't be very tough. So we have 20 rows, 10 into 2, and for all g dot roll, it doesn't exist. We don't care. We're going to get it generated by the IDE. We won't even write it ourselves. Right? So great. Right. So roll we have, but I assume something is going to fail here simply because.
Not sure. It's dropped off again. Is it your computer that's jumping out of the call?
Oh, I know what's happening. I think yeah, I know what's happening. It's my key combination that is shutting down the sharing. Control Shift
That makes
does
sense.
this. Yeah.
That makes
Yeah. G. Okay. Remind me. Okay. So G roll. So the roll is essentially so the roll is 0. Everything is sent to gutter. That's fine. It's failing. So we're going to just remove this, right? Remember, we're trying to do the minimum possible thing to pass the test. If this passes the test, this is good enough for us, right? And then look, everything is green, so we're good, right? So the green is a green tick here. Now what we're going to do is v dot get score should be what? 0. Okay, get code doesn't exist, it doesn't bother us. We'll get it generated, right? Just in time coding, right? If there was such a thing. Well, there's a compiler error. Let's fix the compilation breaks first. Event sessions. Okay. What's up? Now we still have a problem. Right. Not implemented. Okay. We can get that taken care of. Okay, but we need to return something. And the simplest possible thing is 0. Don't care anymore. Okay. So hopefully that should satisfy the test, and it does. Right. So first test is ready. And if this was all the product was what about, we already have the working code. Now, however, we did commit some sins here, like, for example, we put the production code in the same file. We're going to solve that first. So now comes the refactor phase, right? So the test is running. We have assurance that whatever changes we make will fit the tests. So let's just add new item. Okay, that's fine. Game. Yes. Okay, let's just copy paste the game here. And what we're going to do is now we're not going to make it internal, we're going to make it public. And we're going to make these public because they are public. So okay, saved everything. Okay, so we have the test passing, we have done the minimal bit of refactoring, so that's good. We actually don't want the constructor, so we're going to nuke that as well. Constructor is not serving any purpose, so it's clean code that works. Right. So okay, so that's good. Now test 1 is done. Let's do test 2. Public void. Okay, let's do a fact here as well. Okay. Here what I'm going to do is I'm going to just be a lazy bum and copy everything. Excepting this is all ones. Okay, 2020. And what should the score be?
10.
Sure. 20. Right, 1 1 1 1.
Oh, okay, I see.
Right, so clearly the test is not happy, but we have done some crazy things here like copy paste code, but we'll not fix that now. We'll fix the test first. Okay, how do we fix the test? What's the simplest way to fix the test? Simplest way to fix the test is actually you need to compute now, right? Now we're in business. Now we have to we're going to compute this test. What is the way to compute the test? We are going to say private int score, right? And we're going to return the score here. It's the simplest code that will make the test pass. We're not doing anything more, right? And we're going to do score plus equals v. I don't know what that v is, but we'll change it. Okay, so test passed.
Ship it.
We'll not yet. We'll finish the refactoring phase and then ship it. Right. This v is actually pins. Right. And then what we've done is we've done some duplication here, which we'll get rid of. Again, so this is like, we've copied it twice, so most likely we're going to need it subsequent test, most likely. So we're going to put this as a member variable, so that the test becomes a bit more clearer about what its intent is. I will read only, and we can delete this from here, and just rename this. Okay, now we still have the loop doing the same thing twice. So what we're going to do is we're going to say introduce constant, local constant, it's pins. Okay, and then what we have here is introduce local constant. This will be roles. Okay, and then extract this method. And what we do is implement temporary variable, implement temporary variable. Okay, we're done, right? Yeah. Now what we can do is we can reuse this method, the first one, excepting this. Okay, that's because we haven't rolled anything. Okay, cool. So 2 tests, everything dry, all naming is proper. We can read everything, so that's good. Let's get on with the 3rd test. So the thing to note here is that we haven't really written, like purposefully written any production code. It's just to pass the test. And again, remember, this is a kata, right? The kata gives you an instinct to go for the test first, right? And this becomes a very powerful instinct. I can narrate a story if you guys want. How this sort of, it's the same that Jackie Chan movie. The same thing happens here, right? If you repeat this kata like 20 times, 21st time you're starting to write the code, you will want to write the test first. That's how it works. It becomes a habit. Like we go on autopilot. Right. So then let's get on with the rest of the test. Okay. So the next test is going to be fact. Okay. So we're going to test this pair here. Okay, and spare as in we have g dot roll. So spare as in a same frame you get 10, right? So which means g dot roll, it could be 5 and 5, it could be 3 and 7, it doesn't matter, right? So this is spare, right? So comment indicates some problem, right? Not always, most often. So here it means that something is not readable, for which you are right needing to add a comment. And then we're going to roll another one, which will be the bonus, I guess, roll. So the next roll you get a say 3, and then finally roll the rest of the things, send the rest of the things to the gutter. 0. How many more tries remaining? 17.
Yeah.
Right. So ready. Okay. What should the score be?
$16.
Excellent.
Chocolate.
Okay. So
Not
you
my
say,
team.
but code doesn't agree. Okay, that's fine. So okay, so something is obviously, so 16 is the right score, right? So we have 5 5, bonus is 3, and then we add 3 and then 0. So 5 10, 3 and 3 16. But so here's the first thing to note, right? So you got your design messed up here. So get score is returning score that was computed somewhere else. Presumably get score meant you wanted to get the score at that point of time. And roll is doing some scoring work, right? So that's first thing that is messed up, right? So let's fix that. Now if you're going to fix that, you need to get to green first, right? And the reason for that is, right, while fixing you want to stay green, and if you have a red floating around, then you will not be sure whether the red is because of something that you did earlier or is because of your refactoring now. So what you do is you just comment it out, get back to green, fix your design, and we'll come back, right? So now the way to fix the design is, we will, in the get score we will get the score, in the roll we'll just roll. So we'll have to keep a track of read only of the rolls, int new int of it's 20 is the number of frames, plus you are allowed 1 if you hit a perfect game, right? So we'll do 21, right? Ideally this should be variableness, but we'll just keep simple. So now to compute the score, to roll it, all you do is, no, we'll also need a current. No, get back to green. Never work in red or never work in compilation error. Private int roll, current roll, it's always set to 0 anyway. So we'll score it here. So when we say roll, we'll note down the roll, right? So roll of current roll, I can increment it because every time you roll, you go on to the next roll, is wins. Okay.
Should your rolls array be a frames array? Because you have 2 rolls within a frame.
Yes, sir. You're thinking ahead of the code. You get a chocolate for that. Eventually, it will be. You're spot on. But let the tests tell you that, right? Don't predict the code. You will eventually get to that, but you will eventually get to that by the tests telling you to do it, as opposed to right. But you're spot on. Right, but we will not make the change here simply because our tests are not asking us to make the change. That's the only reason, right? And this is, you're doing TDD, pure TDD. Now, that should raise a question in people's minds saying that, hey, if I know I'm going to be doing something, why the hell do I need to wait for my test to tell me that?
Yagni.
Right?
Because I'm always thinking of specification.
Yagni is the call for that. Right, so
Adam.
go for it. You can take another one, it's fine.
I don't know.
Okay, so roles. So what we'll do is, here we'll simply do loop through the thing, length, and let's do a variable bar score equals 0. So we're always operating in the green. So there should be a green all the time, right? So anytime there's a red, the first order of business is to fix the red or a compilation error, right? Plus equals rows of I, and we're going to return score. So this should be green. That will be green. Okay, and we don't need the score anymore because now we have a new way of version 2 of the design that does the score. This might seem trivial, right? But actually you can write, like, the TDD Studio was written exactly in this manner, right? We can walk through the TDD Studio code, right?
You should
Okay.
not be removing that field just yet. You haven't got a test that tells you to remove that field. Save that till refactor time.
It's a refactor time.
Yeah.
So it's superflow code, right?
You haven't got that test passed yet. You're still in the green phase.
Yeah, we're in the green phase, right? So we can
But after the green, you go red, green, and then refactor.
Refactor
Yeah.
is essentially clean up the mess.
Sure. Yeah, no,
So
I'm happy if you leave that field there for now.
why would you leave the field here? Because that's a debt, right? You're carrying a debt forward.
Yeah, but you do the minimum you can to make your test pass, and then you do your factoring. Once you've got that test that you've commented out to pass, then you can go and refactor stuff and remove that field.
We are still not working on the test. We're working on cleaning up the design issues that we created during the previous two tests.
But that's true though. Don't you want the test to go green first before you start refactoring?
No, so just assume that we have not written the test yet. So we've identified design issues because we're still not ready to do this.
Yeah, but why wouldn't you leave that uncovered and know that you have? Yeah, but we already satisfied the previous two. Now we're writing for the third test,
Correct.
right?
Correct.
So we want that to go green before we start the refactoring, I think is what he's saying.
Not exactly. So when we uncommented,
Yeah, that is what I'm saying.
Yes. So when we uncommented this test, if you recall, right, we figured out issues with get score and roll. Roll was actually calculating the score, and get score is returning some cached value of the score. So there was a design problem already, even before we started this.
No, we don't know the design problem until we've written that third test. You should not have commented out that third test.
Yeah.
Leave that third test there, get it to pass, and then think about the refactor.
Why comment out the third test? Because that's what's indicating that it's failing. By adding that third test, it went red. We knew there was a problem with roll and get score, so you change those until all three of them are green, right?
All two of them.
Why not the third one?
Because we are refactoring. We are not writing any new code. We are just changing the design of the existing code.
Then you're working out of sequence.
But the only reason you're writing that code is because you're trying to satisfy the third test.
No. That's what I'm trying to get at. The reason why
but you already had those two working green before you started changing the code around.
Correct.
It's only when you did the third one that you go, oh, okay, that's not going to work, so I need to change.
Okay, so look, we can do this, right? We can do this. We can do what you're saying, right?
Yeah.
Right. The way I'm looking at it is that we caused a design issue and we're just fixing up the design issue before we go any further. But you could do this.
Okay.
You could do this.
Sure.
There's no. So even if you clean up one test later or two tests later, it doesn't matter.
Yeah.
Right?
No, but the point is you don't know you have a design issue until you've got that third test going. And if you're doing a strict TDD, you get that third test to go green before you think about your design and your refactoring.
It seems to follow that flow better.
Okay, sure. We'll keep it that way. Fine. Let's keep it this way, right? So we will comment out. Now let's see what happens. So it fails. Okay, so what do we do? So we have to calculate the bonus obviously in some manner, right? So if I assume roll of I plus roll of I plus 1 equal to 10, which is essentially looks like a spare. Then what we do is score plus equals 10 plus what again?
Rolls.
No, because there's no guarantee that this I is going to be on the frame boundary, and that is the comment somebody had given some time back, right? It should be the number of frames. So the I is essentially overlapping frames, so I cannot overlap.
You could do I plus 2.
Sorry?
You could do I plus 2, couldn't you?
Where?
Where you got I plus plus.
Yes, we will do that. We will do that now. So we will do that now, but again, so it's still not the code is still not lending itself to calculating the bonuses.
No,
right?
but you probably could do it that way.
We would do it that way. We will do it this way, right? So what we do is we delete everything so far, go back to green.
Oh, you're in here?
Yeah.
Oh,
Okay.
Come on in.
Is that alright?
Yeah. We'll have to finish this later, right? Or...
We can just.
Unless you want to do it from your desk.
Yeah, let's go and do it from my desk. Sorry guys, we're being moved out of the room.
Sorry.
No problem. I mean we're overshot. I get the timing.
I think you're going to have to stop that.
Can you guys hear me?
Do you mean us?
Yes.
Yeah, yep, we can.
Okay, so let's go frame by frame. Right. So what we're going to have is, um, let's say equals 0. So we're going to have something called a frame index. We're going to keep this as 10, which is number of frames, and frame index is going to do the roles, right? And instead, what we're going to do is we're going to have frame index plus roles index plus 1. Okay. And then right, we're looping the frame index. So that sort of I is little shady here. It doesn't indicate anything. Let's just change it to frame. Right. So we're just doing pure refactoring here. Things should be green. Okay. So now what we will do is this is fine. This code is not very readable, but that's fine. Let's just get the test to work. So uncomment it. Maybe now we'll have some luck, right? Because now we're going frame by frame. So what we can do is if this equals 10, again it's like a very unreadable code, but that's fine for now. All sins are exempted while you're trying to pass the test. And then what I can do here is 10 plus roles frame index 2. Okay, how does it look? Right, so we've got this green, right? We still have a bunch of things to take care of, but nonetheless the test is passing, so we're at least spare is working, right? A bunch of crazy things we still have to undo is let's just get rid of this core. Number one, let's make this a bit more readable, right? So this is not really indicating to the code, like code should be like English, right? Extract method is spare. And is there anything else that looks a little yucky? There's still a lot of stuff, but let's just get some additional tests going, right? And then let's remove this comment. Extract method role pair, right? We don't need this comment anymore because it's self-explanatory. So how's this look? Great. Okay, so let's go on to the next test. Fact, which is going to be a public void test strike. Right. Now what we do is we simply do a g dot roll, just do a 10, right? Just to indicate that we're being explicit about we've rolled a strike, right? No, g dot roll. I don't know. Throw some random numbers 3. G dot roll, because there has to be at least 2 more for us to calculate the bonus, right? And let's send the rest to the gutter. We don't want runtime. Many. How many we have remaining? So since we're going to roll gutter and
16.
Excellent. If you guys have it still. G dot. I don't know what it is.
One.
The frame. So 10 is essentially you don't get the frame anymore. Right, so the frame is done. Get score should be what?
24.
Okay, you sir are a genius. 24. Well, the code doesn't agree with you apparently, but it is 24, right? So it's 10 plus 3 plus 4 is the bonus. Again, 3 plus 4 is the next thing. So that's 10 plus 14 is 24. Something is busted. We're going to try and make this test pass as quickly as possible, right? Now, the quickest way is else if, let's just compute, right? So rows of current roll equals 10. Condition is not readable, but that's fine. Score plus equals 10 plus what?
The next two roll.
Yes. Right. So frame index plus frame index plus 1. Okay, no, we can't increment the frame index by 2 here because the frame is already over, so it has to be by 1, which means we have to increment the remaining, right? Something is busted. No, it's plus 1. Sorry, my bad. It's not the current frame index. It's the next 2 is the computation of the bonus. Something's busted. What's busted? Okay, we've messed up something. Okay, what's, oops, my bad. What's the failure? But found 17. Why is it still saying 17?
It's completely fucked.
You agree?
No, but it's not even like getting the sphere, is it?
So frame index plus 1, frame index plus 2. What's happening here?
You've said current roll instead of frame index in your square brackets in your else clause. Yeah, there.
Spot on. Yay! Yay! Green is always a therapeutic color. Okay, so we got everything running. It looks a bit unreadable, but I think we're done at least for this test. Let's just,
Yeah. Now you can refactor and remove that current roll field because you're not using it for anything, I think.
okay, let's try that. Sure. Is STRIA is strike. Let's just do some of this stuff. Like we'll just do a. This look a little. Excuse me. What did I do? Let's just rename this properly. So let's say this is spare bonus, and this is strike bonus. And did somebody say current roll we get rid of?
Yeah, I don't think you're using it, are you?
Oh, we are, because we are keeping track of the roll.
Oh, right, sorry, my mistake.
Yeah, that's fine. That's fine. Yeah, it's that's what the tests are for. Right. So this looks reasonably okay to me. If we can refactor this further, but here this irritating comment I want to get rid of. So right, I don't want this comment here anymore because the code should tell you what it is doing. The naming. Okay, so that looks good. So far, so good. We have just one test remaining, and we're not going to think what we're going to let the test tell us what to do. Void. Come on. All right. So we have roll many. What is it going to be? So 10 obviously, and how many?
12.
Excellent. Somebody. Okay, and what the score is?
Yeah, true.
300.
Yes, that is really good. So 300 as in 10 into 10 into 10, right? So we have, was it 300? So we have 10, 10, 10. Right. And then what do we need to change here? Wait. Oh, wait, it's passing. We're done.
Amazing.
We're done.
Ship it.
Ship it. This is it. This is TDD. The idea is that we've let the tests tell us what to do, right?
You get three
And,
rolls.
right. And this is what it is. And if you guys want, you can. I've given the links to two projects that I've done similarly. Yes, feel free to check it out. All right. So that's pretty much it for this session. Thank you for staying back. I will upload it and send you the links. Thank you, guys. See you tomorrow.
I'm still not convinced, Partha. You've still got loads of bugs in that class.
Loads of what? Sure.
Loads of bugs in your in your game class.
Oh, okay. Yeah, sure. Tell me what test?
Okay. Roll a Try a strike and then zeros for the rest of the game.
Public
I don't think you'll get the right score.
bug one. Public void bug one. Okay, fair enough. Roll many. So you want what do you want?
I want a strike on the first ball, on the first roll.
Strike on the first roll, which will be a 10, 1. Okay.
Actually, no, that'll work because it'll go into the is spare and that'll calculate it correctly.
Now, if you have a doubt, let's write the bug.
Okay, you roll a 10 and then roll a 0.
Roll a 10, roll a 0. No, let's do exactly what you're saying. So hang on. G underscore G dot roll 10.
0, 10.
And then roll a 0.
Then another 0. Okay.
Yeah, and then roll a 1 after that.
Roll a 1 after that.
Just one roll of 0 there.
Oh, one roll of 0. Okay.
Yeah. And then after that, you've got 16 rolls left, haven't you? So roll 16 more zeros.
Okay. Roll 16 more zeros. G dot
Should be 11.
11.
No, because it's strike, so you should get the next two rolls, which should be 12.
0 and 1. No. Oh, sorry. 12. Sorry, it should be 12, Partho.
Okay. Apparently it is 12.
Okay, I take it back. Maybe you don't have a bug, but
It's magic. It is truly magic. It is truly magic. I know how you're feeling. I really do. It is truly magic.
No, you see, the problem is that you're actually going into is spare instead of is strike on that first 10.
Just give me a second. I think we extended it for 30 minutes.
Because the logic that you've used to check if you've got a spare will kick in where you've got 10 and 0.
Sorry, what is the test? Just...
Are we implementing?
So go for it. What is the test here?
Okay, I'm trying to think. I can see the bug, but I'm just struggling to think of the test to trap it. The bug is that when you've got your 10 and 0, that's going to go into line 15. That's going to that is spare is going to come true because all you're checking is that your two rolls add to 10. So you actually go into that chunk of code instead of the bit at 20, which is where you want to be. So I'm just trying to think what your subsequent rolls have to be to make that a failure.
Right. Okay. So let's try that again. Let's do another test. And we can work through this. So you want to get into this, right? So you want to get into a spare. Okay. So let's say you get into a spare by doing this. Okay, so now you're here. Okay, what more?
Yeah, no, so that I'm not explaining myself clearly enough. What I'm saying is in that bug one method,
Hmm.
that's actually a strike, right?
Yes.
But the chunk of code that's running, you don't get into that is strike block. You don't go into lines 22 and 23. You're actually going into lines 17 and 18.
Are you sure? Let's check it.
Yes, I'm sure.
But if you go 10.0.0.1, that should break it, right? Because that should
Okay,
be
I
it.
put it on the debugger. Let's try out your
That's just
hypothesis.
about 10.
Maybe it doesn't matter. Maybe it actually works to treat 10.0 like a spare. Except you get the wrong number of rolls. If you went 10.0, 10.0,
Yeah.
that should be a
Maybe you are right. Hang on.
bit of
30.
spare.
Oh, right, 10.0. Yeah, right. You're right. So it should be 30.
Yeah, okay, so what if you went 10.0, 10.33, say? You should get just one of those threes as a bonus.
10.0, 10.33. Okay.
In fact, you shouldn't get, well, 10.0, 10, that's actually a spare, but you're
Is
counting
this right? 10.0, 10.33.
Yeah, okay, so that should
How
So
many?
you've rolled a spare.
give you 20 for the strike, plus 13 for the spare, plus 6, so that should give you 29.
29. And how many more rolls remaining? We have 1, 2 done. 3,
You'd
4,
get
5,
you'd get
6, 7,
14 rolls.
Should
13, right?
14?
20, 13 plus 3 is 36.
13?
14?
14, okay.
Yeah. So
Should
you
it,
have a bug. It was hard to find.
should it be 36 though, the score? Because the first
No.
frame would be 20, and then the next frame would be 13.
Yeah, and then 6 in the third frame.
So 39 then. Sorry.
No, it's
Minus.
29.
Isn't 20 plus 13 plus 6?
Oh, sorry. Yeah, 39 should be.
39.
But yeah.
Yeah, but there's still a bug there.
Okay, let's figure it out. No, so that is good, right? That is good. That is excellent work. So where do you think is the bug? So how do we fix it? Let's go for it. Let's. So this we are sure, right? So this is 10. So you guys have checked it. That's fine. I'm not going to check it again. So this is 39. This is 14 remaining. Okay. So how do we fix it? How many things are
Okay, well, for a start, you need to swap those two clauses around inside your for loop. You have to check his strike before you check his spare.
This is awesome. Okay. You are awesome. You are truly awesome. Okay. What else? Man, you're a genius. What is your name? Sorry, I don't know who you are.
I'm David. We've talked lots about that bug a week or so ago, remember?
David Wallace. Yes, sir. I remember you, sir. Yes.
Okay.
You're awesome. Okay, great. You're awesome.
Okay, I still think there's another bug as well.
How do you even? Okay, let's. You want to do it? Yeah, sure. Let's go for it.
Let me think. Actually, look, it's Partho. It's going to take me more than a couple of minutes to work out what the next bug is, but I'm sure there's another bug there.
Yeah, it's possible, right? It's possible, right? But
yeah,
right. But it's this.
Okay, but I mean, I've demonstrated that by coming up with a fairly small number of tests, you
Yes.
kind of haven't done enough work to know that you're going to get a bug-free class.
Well, I would say that, look, we haven't spent much time thinking through this. That's what I will say. Right.
Okay.
Right. And if we had like done say a pair programming session before coming up, so this was a fairly a quick set of things that I noted down. But you're right that if you don't put thinking into the scenarios that are required, thinking across the thing, then you will get bugs. That is correct. Right. But right, it just means that we have spent less time specifying the behavior of the product, specifying the behavior of the code. Yeah, and the reason why I'm saying this is once we figured out what the test was, right? And there's nothing that says that this test or this sort of combinations can be done earlier. Or it also nothing says that, hey, if this bug we hit in production, we can come back and put a test and put it here.
Yeah. Okay. Fair enough.
Right. But this is really good. I mean, this is really awesome. Specifically you. So
You're too kind.
you're a genius. I'm not too kind. Okay. Okay. This is really nice. Okay, I enjoyed it thoroughly. Shall we hang up, or you guys want to continue? I'm fine otherwise.
Look, I'm not going to work out now whether there's another bug.
Sure.
The code has got a bit too complicated over on the right.
Sure. Yeah, we can change it as well. We can refactor it as well.
Yeah.
Sure. All right, guys. Thanks a lot. Thanks, David.
Thank you.
Okay. Thanks, Partha.
Bye.
Bye.